shadowy, but okay. We are working on inequalities. Does anybody remember what an inequality is? Yes.
Is it like the joke thing for the...
Oh, good question. The worksheet. If you took it home to complete over the weekend, you can turn it into the basket, and I will give you full credit for that. It's fine. Yes, I know that it said everything closes over the weekend, but that's mostly for the online stuff because it's just hard to go back and enable and disable and enable, and it's a lot. But worksheets, if it ever says missing with a Z in focus, just turn that into the basket. I'll give you credit for that. Cool. Okay. Inequalities. Inequalities are that like less than, greater than symbol. You also have less than or equal to or greater than and equal to. Look familiar, I hope? Inequalities, yes. Let me get a highlighter as well. Okay, when graphing these, you may have different methods that teachers have taught you. You could say it out loud. So for example, this said out loud is x is less than -5. So you would put a dot on -5, x is less than, so the arrow goes this way to all the numbers less than. When it doesn't have the line under it, you have an open dot. You probably remember that. So if it doesn't have a line under it, you have open dot. And then when it does have a line under it, it is a closed dot on the number line. So if we were to graph this, x is greater than 5, I would put an open dot on 5. X is greater than, it's all the numbers greater than. So the arrow goes this way. Then here, x is less than or equal to. Since it has that line over it, and it can be equal to 5, it's a closed dot. X is less than, so it goes this way. And this one, x is greater than or equal to, closed dot, x is greater than, so we're going this way. Have your teachers ever taught you a hack for how to do this? There's something that I've noticed that really helps students. This arrow right here, this inequality, if you look at it like an arrow, if the variable is first, so in this case the variable is first, this arrow will match this arrow. And that's a good way just to check to make sure you're going in the right direction. So if the variable is first, if x is first, or y or z or whatever variable they're using, this will look like this arrow. So it's a good way to check to just make sure that you're going in the right direction. Okay, now when we solve inequalities, we solve them just like we would an equation. For example, if I have 2x is less than 10, all I would do is solve it like an equation. Divide both sides by 2, and I get x is less than 5. X is less than 5. The exception, or the thing that's different from equations, is let's say I have 2x is less than 10. If I divide by a negative or multiply by a negative, my sign has to change directions. So if I divide by -2, then my sign has to change in the opposite direction. So then x becomes greater than -5. So I just switch the sign in the other direction. Okay, and here are different solutions that you might get. If the inequality comes out like this, where it comes out with a true statement, like 5 is less than 9, all solutions would be correct for that inequality. If you get something like x is less than 4, which is what we're getting pretty much today, it'll be going in one direction like we see on the number line. And then if it comes out to a false statement, then there's no solution for that inequality. And on to the next page. Now we're going to do some examples. Okay, so for these examples, all we're going to do is we're going to solve the inequality, and once we get a statement that says like x is less than 5 or something simple like this, then we graph it. That's all we're doing. So right here, we solve this just like we would solve an equation. So I'm going to distribute the 2. Am I going too fast, too slow? Some of you working ahead? Cool. So we get 8x plus 2 plus 3 is greater than negative 3. Just start simplifying. I get down to this part and I need to divide both sides by 8. Because I'm dividing by a positive 8, I don't need to change the sign. My inequality comes out to this. X is greater than negative 1. So that's the first part of getting it right. The next part is to graph this. Okay, now once I have this, graphing it, you can number the number line pretty much however you want. Negative 1, 0, 1, 2. I'm not even going to put all the numbers on there. X is greater than negative 1. I need an open dot on negative 1. X is greater than negative 1, so my arrow is going to go this way. And then just make sure that's correct. If my variable's first, this arrow should match this one, and it does. Okay, next one, 11. Distribute the negative 4 to both of those terms. Simplify this. Now for this one, I am dividing by a negative, so my sign needs to change direction. So I'm dividing by a negative 4. So my sign needs to change direction. X is greater than or equal to 12. So because it has a line under it, I need a closed dot on 12. You can number your number line, honestly, however you like, as long as it's consistent. And when you say this out loud, X is greater than 12, so it would go this way to all the numbers greater than 12. So all of these numbers are possible solutions to this inequality. And then you can check and make sure that this arrow matches this one. And the last example, same process. Distribute the 3. Okay, I'm going to divide by 4. Since it is a positive 4, I don't need to change this sign. And I get y equals negative 6 as a solution. Do you find this pretty easy? Easier than the absolute value stuff, right? And then once you get this, you can graph it. It's going to be an open dot because you don't have that line. So open dot on negative 6. You can number your number line however you want. Y is less than negative 6, so my arrow is going to go this way. And then 13, we have a word problem. So now it's applying this whole concept to a real life situation. So let's look at it. I guess all done with this example for us to go on to this. Okay. Javier has at most $15 to spend. So before I look at anything else so I don't get confused, the most he can spend is 15. So whatever he's spending has to be less than or equal to $15. He can't spend over that. So I'm just going to jot that down as a note for myself. He buys a bag of pretzels and a bottle of juice for $1.59. And then if gasoline at the store costs $2.89 per gallon, how many gallons of gas to the nearest tenth of a gallon, nearest tenth, so that's where it wants me to round, can Javier buy for his car? So of this $15, he's spending $1.59 on pretzels and a bottle of juice. I wish that was that inexpensive these days. Could maybe buy pretzels for that. And then gasoline is $2.89 per gallon. So plus $2.89 per gallon. And all of this has to be less than or equal to $15. Okay, now that we have it set up, we can solve it. So subtract 159 from both sides. You could do it the old-fashioned way or use a calculator if you have it. Let's see. 15 minus 159. 1341. So he has 1341 to spend on gas at $2.89 a gallon. $2.89. Remember those days?
Hasn't it like dropped in a while?
A little bit, but not to the Trump days. $2.89. Okay. 1341 divided by 289 is, so the number of gallons has to be less than or equal to, I got a number like this, 4.640138. It says to round to the nearest tenth. This would be this place right here. 4 would keep this 6 at 6. It doesn't round it up. So the number of gallons would be 4.6 gallons. So the gallons has to be less than or equal to 4.6. Okay. So that's it. This is what your homework on Schoology will look like. It'll give you 10 questions. You need 8 out of 10 of them correct for full credit. Computers or phones? Because they're faster. The problem is if I have like 3 or 4 people not doing it on their phone, then it like defeats the purpose. So if I let you use your phones, every single person needs to be working on their homework and getting it done. We have if you get your work done. Okay. You can get your phone, get your homework done. If you finish your homework, work on Schoology or Khan Academy.